So guys, the plan is that how many of you know Python? Is there, okay, all right. If you need a refresher in Python, raise your hands. You need so some of you need refresher in Python. So I will start with the refresher in Python, the very basics. So today's class may be a bit redundant for some of you, but please bear with me. I want to make sure that we all baseline together so that we can make progress together.
She may need to install Anaconda and stuff like that.
Oh, you haven't installed that?
You know how yesterday the instructions for installing Anaconda have been posted on the site.
Okay, and you can sit with, yeah, Kate can help you and so forth and set up. Yeah, so for now, just follow along the topics. Huh? So, how about you? Do you have Anaconda and everything installed? Okay, good, wonderful. All right, guys, and all right, guys, so we start with the Python primer. Python is a very simple language. It is no wonder that it's become so very popular for data science. It's a general purpose language. People use it for everything these days. They use it to write their web services. They use it to make UI sometimes. They use it for all sorts of backend system administration. They use it for DevOps. And increasingly, they also use it for data science. In the world of data science, the languages that were popular were R and three languages principally, R, Python, and Julia. R used to be the king of the hill. Increasingly, people are moving to Python, and there's some forward-looking people are also moving to Julia. But we'll stick with Python because that's where the momentum seems to be, or the core mass seems to be. The Python language is called a scripted language. In other words, you don't have to declare the data type of anything. You can create variables. What are variables? Variables, think of variables as boxes in which you can put anything you want. So a box has a name and a value. So if X is a box, when you say X is equal to 5, what you're in effect doing is, imagine that you're creating a box, labeling it X. Right? Think of one of those brown boxes in which you receive your Amazon packages or something like that. And it has a label X. And inside the box is the number 5. And you could choose to put something else into the box if you so wish. Right? So the easiest way to think of Python as a scripting language is, in a scripted language, boxes are like brown boxes. You can put anything you want. Whereas in languages like Java, C, C++, those are typed languages, which means that you can put potatoes, only a box meant for potatoes. And you can put, I don't know, you can put, let's say, electronics, only a box meant for electronics. That's a sort of an intuition behind it. So more formally, a variable of type int can only contain integers in it, numbers in it. Like a variable type string can only contain text in it. So they differ from that. So those are typed languages. Python is an untyped language. So you can take a box like a X, a variable, and put just about anything you want into it. The type is inferred by the value you assign into it, you put into it. Okay, so X is equal to 5. Now, there is a facility in Python which I highly encourage, that whenever you create a variable like this, you can actually be more precise and say, hey, I meant the box X, the variable X, to contain integers is equal to 5. When you do it, it is called type hinting. It's a really good practice. I follow it all the time. As far as possible, use type hinting, because the Python IDs like PyCharm, etc., they make it very easy to catch errors in your code. Right? Now, you can write Python code in just Jupyter notebooks, and it's one of the things that we will do in a little bit. I'll explain that a bit. You create these variables. You can do these statements. If X is greater than 4, Y is greater than 6, you can print it. These are FL's statements. Now, remember, this is a refresher in Python. If you don't know Python at all, the first thing I would say is give this week to picking up Python. Are we together? Give some time to quickly picking it up. Now, remember, it is just a refresher. So what it means is facilities in Python is you can convert a string. This is a string I don't know, guys, could you please not leave the door open? The AC is running and outside is hot.
Yeah.
Actually, Raj, you know the thing, the knob at the top that auto pulls it? I don't know if you can see that. Push it back. Oh, it doesn't matter. I'll do that. Yes. Okay, leave it. I'll take care of it. Don't worry. Yeah, I'll do that. Okay, guys. So Raj, leave it. I'll come and take care of it. So certain conversions are easy. When, for example, if you create X is equal to potatoes, it is of type string. So when you give a string conversion, it remains string. On the other hand, and Y, a string can be converted into a number. In other words, in quotes, if you say 1 to 6, and you want to convert 1 to 6 from a string to a number, from a text to a number, you would say int. If it can be interpreted as an int, it will get interpreted as an int. But sometimes it cannot be. Like this text, 125.4 is fine, but if you put the word apples next to it, that doesn't look like a number anymore. So if you try to convert it to a float is a floating point number, it will bail out on you. It will throw you an error saying could not convert it to that, right? And once again, if you like, these are the basics of languages, of variables and conversions and so on and so forth. Spend some time picking up Python. If you're familiar with any programming language, then this will look relatively straightforward to you. Now, so this is expected. It will throw something called a value error, could not convert string to float for this, for understandable reasons. Now, when you think of a list, a laundry list or something like that, in Python, lists are that literally by square bracket. By the way, unlike Java, unlike C, C++, where lists and arrays are different things, in the basic sense, in the language of Python itself, they are the same. Square bracket means it's a list. So you can go on adding elements to the list, right? So here we are adding, here's a list, we are printing out its length. You can reverse a list, you can sort a list, you can reverse sort a list. So if you were to run this, for example, you will see that the list is this, its length is this, reverse, increasing order, decreasing order. You can append things to a list. How do you add another thing to it? You can add a list to a list using extend. This part is something that people often get wrong. You can't do append of one list to another. You have to do extend, right? You can find the index of at what location is something. You can insert at a given location something else, remove from the list. So these are list operations, in other words. Many things you can do. Now, list operation is something you'll be doing all the time in Python. So it would help if you pick it up. By the way, those of you who don't know Python, it's a very easy language. That's why it's the first language you teach kids, Python, quite often. Right? The amount of Python that we need for this course is very minimal. Very minimal. But nonetheless, if you're encountering it for the very first time, it can look intimidating. But if you give 2 days to it properly, you'll get the hang of it. It's not hard. Right? In fact, many people here in this class, they started out not knowing Python and they picked it up along the way, literally. Right? So pick it up from some basic book, extend. And it has support for loops. So this is a game you can play, and this code is there. Run this code. It is guess a number between 1 and 1,000. Now, when you have a number between 1 and 1,000, those of you who know binary search will, of course, know how to quickly search through it. But if you don't know, it's a game. You get only 10 turns, and you have to guess the number, right? So I'll just walk through this code. The computer comes up with a number in its mind, which it doesn't tell you, the secret answer. Then it maintains a state, whether it is solved or not. Then it gives you a turn. It says print a number, and then it will take a guess. It will ask you to input a number. When you input the number, it checks whether the number is in the right range. Else it checks if the guess is the number, then it marks it solved. Else, if guess is greater than the number, it says guess is too big. Otherwise, guess is too small, and so forth. So if you want, so this is called a for loop. It keeps on running. for 10 turns. Right? And if you still fail to do that, it will tell you you have failed to do that. Again, I'm going a little bit fast over this. The same thing you can write as a while loop. What are loops? Loops are doing things again and again till you achieve, till some condition makes you stop, right? Remember, the stop condition is important, otherwise you are in trouble. So while turn is less than 10 means you have to keep increasing the value of turn somewhere. Every time you take a turn, you give user a turn to guess a number, you increase the counter, right? And check, next time you do another, you do it again, you check whether all 10 turns are over or not. This is important. So if you take a shampoo bottle, it will say apply, rinse, and then it will say repeat. If you actually follow the instruction, you'll be done with the entire bottle in one shower. Right? Because it has no stop condition. Right? So that's not a good code.
That's we miss the turn increment.
That's when you miss the turn increment and checking whether you're done. They probably want you to do it twice or something like that. Repeat. They probably meant to say repeat once. Right? I don't know if the shampoo bottles even now say that, but I remember reading it many years ago. Right. And counting number of lines. Likewise, if you take a file, you can count the number of lines. Now, those of you, the reason I mentioned this text is, those of you who are familiar with Java, C, C++ would remember that the same thing is pretty long bit of code. In Python, this entire thing is very short. Right? In a line, you can do this. Much easier to do it in Python. Most of the things you'll find that as a language, Python is a simple language, elegant language. It does a lot of common things in 1 or 2 lines, right? Which is why it is such a pleasure to learn quickly and become productive in, right? So, and once more, today, usually what happens is when I teach, give this notebook, I walk through it. I give about 4 or 5 hours teaching people Python. We don't have 4 or 5 hours. We have to move through with the lab. So I'm just walking through it. But if you do need this session, those of you who want a Python primer session, let the TAs know. We'll arrange a time and we can teach it to you from scratch. Right? At the same time, pick up a book on Python, basic book on Python, and try to make some progress, and we'll be happy to teach it to you. So printing the words in a file, etc., etc. So we can do all sorts of things. If you notice these things, these are very short amounts of text to do many common things. Right? I won't go into a lot of this. There is such thing is object-oriented programming, but at this moment I won't go into it because it will eat up a lot of time. Then there is NumPy. NumPy is for doing numerical computations. I'll just spend a little bit of time on it. It is the first machine learning library you will encounter, numerical computations library you will encounter. So to motivate it, I will, this is worth talking about a little bit. When you take 2 lists, say length, suppose, and so let me frame the problem. Suppose you are a person who is going and measuring different pieces of land. So you go, you're a surveyor, so you measure this and you say, this is this long, you measure the width, it is this is the width. So you have 5 pieces of land, you get their lengths and you get their width. Now you have to find the area of each piece of land, right? So how would you do the area? It turns out that if you use raw Python, you would do area by multiplying each length with each width, right? And when you do that, you'll get your answer. But when you look at this code, it looks so different from the simple intuitive mathematical expression, which is length times width. And you wonder, wouldn't it would have been nicer if the Python syntax was easy like that? It would look like math. It doesn't look like math. It looks, frankly, this is where Python, despite its simplicity, is not simple enough, isn't it? And if you try to do area length times width, you'll realize that it wouldn't work actually. It would give you pretty bad results. In the same way, if you want to find the perimeter of each of the piece of land, perimeter means outer, the fence length, right? You will see this is how you would do, right? As a rectangular piece of land, there are two fences this way, two fences this way. So you would do it like this. But if you try to do this, you would realize that actually this is a disaster. It produces something that you don't expect it to produce. This is clearly incorrect, and the right way to do it would be using, if you this complicated Python syntax. And once again, you say, well, this looks so much more non-intuitive than this beautiful mathematical expression, right? So it turns out that there is another way of doing it using NumPy. NumPy is a Python library that has been written over the Fortran and C libraries. Remember, I said that most of the numerical computations are written in Fortran and C. You don't want to reinvent the wheel. What has happened is those libraries have been battle tested quite literally for 40, 50 years. Right? Something that has been bottled back 50, 60 years, actually, decades and decades of testing has gone into those libraries. A lot of very serious works are done, weather prediction, right? The nuclear equations, right? Our spaceship, sending things to space and so on and so forth, NASA work, they are all done, and particle physics, atom smashing and so forth. All of these things have been done using Fortran and C libraries. And they are very mature. Numerical libraries are extraordinarily hard to get right. So for example, I'll give you an illustration. If I were to give you two numbers and ask you to find the average, two numbers X and Y, what would you do? Your intuitive sense would be do X plus Y divided by 2 in your code, isn't it? And all of you are programmers of some sort, you'll do it like that in code. But actually that happens to be wrong. If you do X plus Y divided by 2, you will not get the right answer, always. Can you guess why? Yes, excellent, Sanjeev, because the size of the register, because if X and Y are close to the maximum size that the data type can hold, integer can hold, then X plus Y will actually give you some bizarre value, right? It will overflow, right? Because computers can't count till infinity. They can count only up to a finite size. Once that size is exhausted, you're done for, right? So if you add two very large numbers, it will overflow. And so the right way to do that is, now I'll let you find the right way to do that, X plus Y. But it just shows you that even if I can't do X plus Y over 2, and I need to be ultra careful, it should give you a sense how hard it is to do numerical computations correctly. So these libraries have been created after years of battle testing it in very mission critical situations, right? So NumPy is literally a layer, Python layer on top of it. One of the beautiful things of NumPy is you don't need to know Fortran, of course, but also look at the syntax. You want to compute the area. Isn't this a lot more elegant than before? Compare length times width. I create two variables, length and width, and compare it to the previous one. Instead of writing area is equal to blah, 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 isn't it far more intuitive to be able to say just length times width, multiply the two and you get the answer. Perimeter also, literally the math equation, whatever you would write in mathematics, it becomes that. That is the beauty of NumPy. It makes your code very close to the algebraic equation that you would write, basic school algebra equation that you would write. And that is its beauty, right? And you could do obviously complicated things. NumPy arrays can contain numbers and other things, true, false values, etc. They will have certain consequences. So when you add a number and a true, false value, truth is considered 1, false is considered 0. It will go added. Now these arrays can be 2-dimensional or 3-dimensional and 4-dimensional. What are 2-dimensional arrays called? Matrices. If you remember your school mathematics, matrices, you'll end up with matrices. NumPy also gives you the ability to do statistics, right? Descriptive statistics. You can take a bunch of numbers. You can say mean. and it will give you the mean and so forth of arrays of numbers, right? And you can do dot products, so x dot y, you could do using this. So all of these operations, if you want to find the histogram of a bunch of numbers, random numbers, you could do it like this, right? And I won't go into it. Very basic operations. Everything that you did in high school, sine, cosine, they all come as functions. Literally, whatever the math symbol is that you would write in school algebra or trigonometry or coordinate geometry, just put the NP dot before it. So to create a sine wave, sine function, do you notice that all you do is you put NP dot, isn't it? It is as easy and intuitive as that. If anything looks even simpler than Python, it is NumPy. Fortunately, that's what we do with data science. We use NumPy, right? Now,
And for dot products, there is now an even easier syntax. You just
ampersand,
have to say X and then at the rate of and then
At the-
Y.
X ampersand. Yeah, that's right. That is it. X ampersand Y. A very good point that Kyle mentioned. The ampersand symbol, this one could be replaced with X ampersand Y. Right? It looks even more intuitive than that.
Yeah.
This is a NumPy, very useful library, and this is, we went through it blazingly fast. Now, NumPy, good and bad of it. NumPy is just a set of functions, lots of functions. How many functions are there? The last I checked, a few hundred, right? Do you need to know how all those few hundred functions work? Not really. Most of the time you use common things like dot product, sine, cosine, create random values, maybe a handful of 10 of them, right? So saving grace, there are lots of NumPy cheat sheets available. So in this world of data science, the cheat sheet concept is very, very effective. So let's go and search for, and I believe we have added it to the course portal. Kyle, if not, let's do that. Cheat sheet. If you look for NumPy cheat sheet, you will find lots of cheat sheets that people have created for NumPy. Let's look at this. Here we go. In my view, this cheat sheet is way, way too complicated. It's too big a cheat sheet. You don't even need so much. But what you do is you just keep it on the next to your table, on your table next to your computer, and you keep looking at it. And most values are self-descriptive. But let me take a simpler cheat sheet. This is too big. Python for data science.
And most of it will be covered in pandas anyway. You won't directly be using NumPy much.
Yeah. So yeah, this one-pager cheat sheet is probably better. Yes, this is more than enough. One single page cheat sheet will just help you do most of your work. And because in pandas life gets simpler, you don't have to worry too much about it. Pick it up, guys, NumPy. Now, even these, you won't use most of it. You will just use a few of these as you make progress with the course, like Kyle is mentioning. Then the next one we will do is pandas. I will let Kyle take over and explain pandas to you. Kyle, would you like to do that?
Yeah. Yes, sure.
Here and explain pandas.
I cannot share my screen.
I'll stop sharing. Well, I thought you were the host. You're not the host.
No, I'm not the host now.
Can you share now? Check if you can share.
Yeah. Okay.
To see your screen. Okay. Yes.
So just a short reminder of why we need pandas data frame. So in the morning, we just saw about these ice cream sales and temperature, right? So generally how we represent that in a tabular format is that we have a column, we have multiple columns for the features and one column for the target, right? So this is how we would actually represent it. And so each row represents observations and each column represents features, right? And our target variable is also a column in our data, in a table. So to represent this format in a pandas data frame, it's usually like this. So we have columns and then we have these rows. And so this is why we actually need a pandas data frame to represent our data, and it's easy for manipulation. So that's how it is. Let's just go back here. And so why do we use data manipulation? Like, why do we use programming languages instead of spreadsheets? It's just to keep track of manipulations and to automate manipulations. So in spreadsheets, it's not possible to keep track of what we do. So Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of Python programming language. So we can import pandas using import pandas as PD. So PD is the convention that we use. For NumPy, it is NP. So wherever you see PD, it means it's we're using the pandas library. So in pandas library, there are a few terms that will be thrown around this course. So the first one is a data frame, and that refers to the table as a whole. So when we import our data set, we will import them into a data frame. And like we said, so each column would represent features, and the rows would represent observations. So, and similarly for the row in the data frames vocabulary, it's called an index, right? So each row is identified by its index. So for example, we say this observation, we can identify it by the index 4. And similarly for columns, we have labels. So these are numbers, and these are usually strings by which we identify. So for example, temperature could be a column label. So that's a column, and they are identified by column labels. Now to load a data set, usually you can load it from different formats. For example, CSV, Excel, SQL, JSON, TSV. So you can download it from different formats. So in this case, we're using the simplest one, which is a CSV file. So a comma separated file, and to import it, all you need is to you need the path, and then you say df equals pd dot read CSV, which will read the data, which will read the file. Okay, and it will store in a data frame. And in Jupyter Notebooks, you can just say df, and it will format it beautifully in a table for us to view, right? So I've just downloaded this this particular data set, which has 4 columns, and let me see, 31 rows. Okay, so but how do we actually sorry,
one more thing to emphasize, go up a little bit.
Mhm.
See, pandas, this read CSV or read anything is pretty prolific. For example, you notice we gave the source as a URL. It's not a local file. It's not on your laptop. It can just read it off the web also, as it is doing now. Okay? Part of the power of the pandas, most things are very flexible. You don't need, it's very flexible, whether file is remote or local or set. And it can even read zip files, right? And things like that. So it's just something to remember. Kyle, please continue.
Yeah. Okay, so at this point we have our data frame loaded. So how do we analyze it? So what all can we get out of it? So that we can start with just inspecting a data frame. So to inspect a data frame, the first thing we generally do, so in all our notebooks, we will start with this. We'll start by seeing what is the shape of a data frame. So in this case, it's pretty small, so we can actually see the entire data frame here. But when there are really large data frames, you won't be able to see all the rows and all the columns, right? So in that case, how do you get a sense of what your data frame looks like? This is what you do. So the first thing you do is analyze its shape. So the shape refers to the number of rows and number of columns, and it is returned to us as a tuple. Okay, so we just say df.shape, and we get 31,4. So we have 31 rows and 4 columns. So we get a basic idea of our data frame. So next, what we want to do, we want to see a few of the observations we have in our data frame, right? So in this case, I want to see the first, say 10 rows in my data frame. I can just say df.head and then pass in the number of samples I want to see. So samples, observations all refer to the rows, right? So so we want to see 10 samples. We can see 10 samples like this. So these are the first 10 rows. Now I can also view the last few rows in my data frame. So the default value for the number of rows to be displayed is 5. So that's what you see here. And if you specify a number, those many rows will be visible, right? So that is df.tail. Also, okay, we might want to know a little bit more about the data set. So we can see that the data set records minimum and maximum temperatures measured for each day of January 2010. So when we look at this data frame, we see that, okay, it starts from 0 and then goes to 30, and then the date is also provided. So we get a sense of what the data set tells us. So we see that the temperature is measured in Kelvin because it's 167, and then for them to be meaningful anyway. So however, we do not know if all the records are from the same station or from different ones. So if we cannot view the entire data frame at once, we'll never know if the station names are the same, right? So that information is still missing. So okay, so the next thing we would like to know is what are the types of, so each column, what sort of information it is recording? Is it a string or integer or float? We can check that using df.dtypes, right? So, and it will say what sort of what is the data type of each column in our data frame. So we start with station, date, tmax, and tmin. So these are the 4 columns in our data frame. And what is it? So we see that station is of object type. So which means that this is a string. This is the others are all integers. Okay. So here date is stored as an integer data type, which will not allow us to perform date time calculations. Okay. As you can see, this is all put together as one integer. But in general, you might see in most data sets that you look for online, you will have a date column, and it's very useful to know how to like manipulate date. And most times date would be set as the index because that identifies your rows. That uniquely identifies each observation. So it's a very important data type, and that is date. So how do you work with dates is, first, if it's an integer data type, you would want to convert it to date time. So pandas provides you a way to convert your integers or string date time objects to, the date time objects. So we have a separate format for that. So we'll convert date column to a datetime object. We will learn about datetime objects. Okay, this is from the data wrangling course. So you learn in more detail in that course. So here we're just going to just brush through it. So here to convert this column, we use this syntax, right? So we just say it's a format that you specify, and by specifying this particular format, you can read about this. Just search in pandas, and you can just type in datetime manipulation, and it'll sort of explain what it is. Okay, so now our date is properly formatted, right? So that's good. Next is to string data type. So how do you convert say a column from object to string data type? Pandas actually recommends it, that you store strings as strings and not as objects. So so how do you do that? So that is also pretty similar. You just say df, you call that particular column, okay, and then you say as type. So what type do you want it to be? And then here I want it to be a string. So that is that. So you say just replace the original column with the modifications that you make. right? So now when you check the data types of your data frame, it should show that it's of string data type. So we will, I mean, when you download data sets, you might need to do some of these manipulations before you can analyze it. So it's good to know. Then comes the most important part is getting out statistics from the data, right? So so pandas conveniently computes the descriptive statistics for us. So if you, in the previous notebook in NumPy, we had this NumPy functions that we use, right? np.mean, and then we passed in an array. So it's more convenient here because we can calculate it, compute it for all the columns, and we get a lot of descriptive statistics that we can use. So say count, mean, standard deviation, minimum, 25th quantile, 50th quantile, 75th quantile, and the maximum values. So when I say df.describe, it will actually only describe the numerical columns which are of integer or float type. But or sometimes even the date time will work, but it will not show, say, it will not describe qualitative variables. In that sense, for example, we saw station is of string data type. So what does it even mean to say the minimum of this column or maximum or standard deviation or mean? So it makes no sense here. So these are called categorical variables. We will see them in this course. And also date also doesn't make sense that you say 25th quantile and all. So these two need a different treatment. So how do you do that? We say df.describe, and we also say date time is numeric equals true. So then the datetime data will be treated as numeric data, and we will get all these statistics out. Also, the second thing we do is we say include all. This is something we'll do very much in this course. Every time you use describe, make sure to use include all, right? So only then all the variables, you'll be able to see the statistics for all the variables. So when I say include all my columns are visible now. So I see four columns and then all their descriptive statistics here. So one thing you might note is that for date, tmax and tmin, which are numerical columns, we see these statistics. Okay. And okay, yeah, this is also an important point. There's something called nan, which is used when there is no variable here. Sorry, there is no value here, right? So it's equivalent to null value. Okay. So for mean, yes, so mean for the station column, we see that only count, unique, top, and frequency are shown. So which means that, okay, so this is a categorical variable. So the only descriptive statistics that make sense are count, unique, top, and frequency. So count tells you how many variables and how many values are there, how many unique values are there. So it's just one. So now we get to know that the data set was for just one particular station, right? So earlier we were not able to see that from just head and tail. When we do descriptive statistics, now we know for sure that, okay, that data set measures the temperature for only one station. Then top tells you which is the most frequent say value, and in this case it's just the one single station. And then what is its frequency, how many times did say the top value appear? So it says 31 times. So for categorical values, only this makes sense. Mean, min, all of these statistics don't make sense, so we get nan values, right? Okay. So next is to change index. So earlier we had indices which were just integers, right, starting from 0. But in most cases, what we set as index actually identifies each row uniquely. So we might want to look through a data set and find the column that actually sort of, which identifies our rows uniquely. And in this case, it was the date. So the date column does that for us. So we set that as our index. To set index, we have the syntax here. You can verify this notebook whenever you want. There's no need to remember all these syntax, but just know what they do and what you can do with pandas. Okay, so and in this case, what we did was we set the index, and now we are able to view it, right? So let's just see if this change was actually made in the original data frame. So we say df.setIndex. Does this actually go and change in the df data frame? Actually not. So it doesn't change. So date is still a column here. It's not the index. So what's happening here is, this is something you'll face all the time. I make this mistake even now. So what you have to do is, when you make this change, you have to either set in place equals true. So then let me show you. Yeah. So either you set df.setIndex and say in place equals true, then the change is actually made in the data frame. Otherwise, what happens is the change is only returned and it is not stored. So there are two methods you can follow. You can either say df equals df.setIndex or say this. So if you face this trouble, the first thing that should ring a bell is, okay, did I actually make the change or not? So when you do multiple manipulations like this, you might miss out on one of these and it might cause trouble. So it's good to note. So the next part is visualization. I think, yeah, it will be covered in the next notebook. You can end it here. Yeah, I'll stop sharing. Okay. Yeah.
Kyle, are you done?
Yeah, I'm done.
Okay, give me a moment.
So people like Rita and the other, it may be useful to make them understand what this Python notebook and how this Anaconda kind of works, because I think they may be clueless of what Kyle is saying, like, and all those cells,
What they mean and
what
so
they
forth.
mean, because that would be a good introduction. And then, I mean, it just,
Yeah, let's do that. Let's do one thing. Kyle, during the week, let's say Monday evening.
Yeah.
Let's give Monday evening for you guys to give a very basic from the scratch introduction. Would that be okay? Kyle, you and I will do it on Monday evening. US Monday evening, your morning, your Tuesday morning.
Okay, yeah.
So the idea is we show the Anaconda dashboard, help them set it up. Pretty much you did that, I believe, yesterday, but we'll do it all over again. And then big the introductions to the Jupyter notebook, like what does it mean, what a notebook means, what it is to do these cells. That's what you want, isn't it? So we will do all of those basics. Today, we could do that, but a lot of people are a bit familiar with these things, so it will slow them down, but we'll do a special session for you guys. All right, let me share my screen. Am I sharing my screen now or not? Yes, we are. So the last thing I'll do, and again, guys, I realize that today may be the hardest class because we covered a lot of territory, introductory territory, and in the lab also we are moving relatively fast. Usually will not be going so fast. This is hard to different people to different degrees because people are at different levels. But hopefully at the end of first week, we'll all baseline to the same place. And you will notice that the pace will be slower after that. We won't be moving so fast. It'll be moving much slower from a lab perspective. So let's take another. See, one of the things people do in data science is data visualization. Right?
Asif, I was not able to find those data sets
That is all right.
necessarily the last. Yes, sir.
We'll live with whatever is there. Right? So don't worry. I'll find it and I'll add it. Right? It must be there somewhere. I'll add it. So when you try to visualize, why should you visualize data? You learn a lot by visualizing the data. This is one of the great lessons. One of the things we will do in a homework or a lab is we'll look at something called a dinosaurs data set. And it's quite amazing, actually, what it tells you. There are data sets which can be vastly different, but their mathematical properties look identical, right? And you don't know that they are different things till you actually visualize them. So remember, our human eye is the most marvelous learning engine. It can see things in the blink of an eye, right? It's a very survival instinct. In the forest, when there's a tiger there, you don't have time to ponder over it. Is this something that I need to worry about? Or what is this? You don't have time. If you want to survive, your mind has to instantly get it and run, isn't it? So human eye has evolved to be a marvelous learning engine. And because of that, we need to leverage that. Whenever we encounter data in real life, the first thing we should do is we should visualize it in ways. Now, today we'll go through the mechanics of things. Matplotlib is the default and the standard plotting library that people use in Python. It's quite easy. You take a data set. I'll just give you an example. You read the data set. How do you read it? Kyle just showed you. You can read it into a data frame, pandas data frame. If you want to scatter, you want to do a plot of it, just plot the data in the XY plane. You can do scatter. It will plot the data. Right? Scatter plots are things we all are familiar with from our schools and so forth. So let me slightly decrease the font. You can scatter it, one line. The beautiful thing with Python is, and Matplotlib is, quite often the simple thing that you want is one line. I don't think there is any, even if you use some visualization tool or Excel or something, you'll have to do many clicks before you get a scatter plot, right? But in Python, and especially with Matplotlib, most visualizations are just one-liners. In one line, you can get what you want. Now, this one-line syntax comes in a few variants. You could do it using data frame itself. You can now this plotting is built into the data frame, pandas data frame itself. You can ask the data frame to plot. Again, it's scatter, XY axis. There are a couple of variants of it producing the same result. If you want to build a histogram of the data, once again, this is XY data, just say hist on the data frame. It will produce a histogram. What are histograms? Frequency distribution. Frequency plots are called histogram. It will make a frequency plot of the data, right? And there are, again, a couple of different syntax that you can use. Then comes an interesting fact. Sometimes people say, this looks a little boring, right? I don't like the looks of it. I want it to be a bit prettier. So this pursuit of prettiness or aesthetics and graphics or in data visualization, people go crazy over it, right? And they do a lot of things. So there are many libraries. For example, you could use another library called Bokeh. Bokeh will produce a data. You notice that it has become very interactive now, and you can zoom in, you can move it around the data. You can the whole thing becomes interactive. You can zoom in. Right? And to use this library with all of this functionality, it's still just one line. Right? You just have to make sure that you turn on those libraries. Right? And then it remains a one line, the same one line of code will produce the library, and you have the ability now to zoom, to pan. This is called panning, and so on and so forth. And you can keep playing with it, like zoom out and so forth. We won't go into that. You can get back to the original library. And there are other plotting things. Now, when you write this, one of the things is data or data science. tends to be close to mathematics. And people like to remember that when I was writing it on the writing board, I was using symbols like beta naught, beta 1. Do you remember? Right, in the notebook I was using. It turns out that in Python, when you do this using matplotlib, it's very, very friendly to mathematical symbols. But there's a catch to it. All mathematical symbols on the computer broadly is written using a mathematical programming, sort of a notation, typesetting language. It's called LaTeX. Right? So any research paper that you find in these fields, they are all written in LaTeX. Why? Because it makes it very easy to write mathematical symbol. Well, easy is relative. The first time you see this notation, you're like, it just doesn't look easy, right? So you see this thing, math, like when you read this line, and I'll just emphasize it. Where is that line gone? Yeah. Well, I went far down. Let me go up a little bit. Yeah, when you look at this line, well, in the beginning, this looks pretty obscure, right? What is this dollar symbol and this math BF, X, long arrow, dollar, and this Y? I'll explain what it is. You're saying, I'm going into the mathematical symbol world. Whenever dollar and dollars, they are the boundaries of entering a mathematical symbol. Anything fenced by the dollar symbols is now you're in the math land. You're talking mathsy. Right? Now, in the mathsy language, math BF saying, make it bold, like in bold letters. So this Y, make what in bold letters? The Y, letter Y. So do you see the Y here, where my mouse is? It may not be obvious, but actually this is a bold Y. Right? And long right arrow, backslash long right arrow. What is that? Do you see this symbol, this arrow going up? That is a long right arrow, right? Now, whether you use a math notation or not, it's up to you. Most people don't. But the beautiful thing about matplotlib is, in case you want to get mathsy, and you know how to go mathsy, speak mathsy, which is LaTeX, then, well, your plots can look, you can nicely sprinkle, just as you would sprinkle salt and pepper over your dish, you can nicely sprinkle mathsy symbols all over your plot. Which is what we are doing here. And you see, linear relationship is Y is equal to this. This is how I wrote this line. You can see that. So that's sprinkling the mathsy symbol here. And you can change the color and you can go. So by now you realize that what was one liner, you can start getting more and more fancy. You can do, oh, you can add, and so let's see what all things we did. Look at this plot. And this guy, what did we do? You're adding annotations to it. Oh, sometimes in graphs or plots, people point out something, people will say, oh, look at this point, here is something special. Oh, look at this point, something else is special. People do that in your textbooks, etc. Right? They make arrows and they do that. So how in the world do they do that? Oh, it turns out it's not hard. The facility is there, but by then it no more looks like a one-line code. It begins to go a little bit more complicated. So the point I'm trying to make is a lot of things are possible, but with plotting gets into the world of data visualization. Here's the good and the bad of it. It's easy, but it's verbose. To do every tiny thing, you have to write a little bit of code, right? And you put all of these pieces together and you create something that looks unique and nice. Like this graph, you would agree. It is pretty explanatory. Right? It says a lot, but to say a lot, you have to write a little bit more code. And I won't go over this code. This is part of the matplotlib. You build skills gradually. Now, remember, why am I showing it to you? Do I expect you to do it the first day? Absolutely not. As you start the course, the only thing that I expect you to do is be able to write one line. This line, I hope you find it easy enough. This line, plot.scatter X and Y. Would you agree that that is easy? Right? If you can do that, you get your plots easily and your work is done. But this is just to illustrate to you that much more can be done if you so wish. Right? So what happens is that you do things in your experimentation. But one fine day you discover something, and then you want to go publish. You want to write a research paper about it, isn't it? So when you write a research paper, the first time your paper is rejected, even if you have done a brilliant thing, because the reviewers will tell fonts are wrong, typesetting is not nice, and the plots look ugly. Literally, that's what they'll say. So then you have to sit and make your plots more professional, your text better, and so forth. So this is part of the journey, pointing it out that you can actually do that. Right now, you can often see sometimes people put multiple plots together into one plot, isn't it? These are called multi-plots or subplots. These are subplots of a plot. This is an example of taking a few data sets and then plotting it out like that. You can do that, and I won't go into this. This one, the data set is missing, but pretty much it proves the point. So this is Matplotlib. Are we together? So today, because today is the first day, and we are covering a lot of territory, and we need some time for everybody to come back to the same page and baseline. I won't teach you more. I won't actually go into regression, the topic that we covered. Right? We won't do that. We'll do it from the next week. The actual labs in machine learning, we'll do it from next week. But this week, guys, your main tasks are, here are the things we need to do. All of us need to install Anaconda. Right? So you'll see a lot of references to snakes here, Python, Anaconda, and whatnot. Right? So this space is littered with that. The Python versions are littered. So install Anaconda, the latest Anaconda. And the latest Python, there's a reason. Even if you have Python and Anaconda on your machine, like Sanjeev you have, wipe it out. The reason is recent versions of Python are much faster. And the Anaconda has also support for, much better support, for example, for Mac and other things. They just came out with support for the M1 chip. Right? So in case you have the latest hardware, it's worth installing the latest versions. So do install the latest version of it. Make yourself familiar with Jupyter Notebook, because we will spend our whole life here in Jupyter Notebooks. Now, what in the world are Jupyter Notebooks? So Monday evening, we'll give you guys a walkthrough and tutorial of Anaconda and Jupyter Notebooks. Right? Get you started. It's very easy. Jupyter Notebooks are just like notebooks, like digital notebooks. What you're looking at is a Jupyter Notebook. Data scientists create their notebooks, their work, their thinking, all in Jupyter Notebooks. Right? So Jupyter is your friend. You'll spend most of your time with Jupyter Notebooks. Now, as a bonus, if you want to write more extensive Python code, you may want to install PyCharm. It's an IDE, it's a development environment, but it's only if you're familiar with Python and you feel like writing reams of code. In this course, you won't write, you'll almost never write more than 4 or 5 lines of code, right? Because you're here not to do extensive programming. You're here to do data science. Right, learn this field. So never vast quantities of code, just tiny bits of code. Right? And it is amazing what tiny bits of code can do. Right? This field is about thinking through data, not about writing reams of senseless code. Right? So that is that. So get that thing there. If you don't know Python, immediately start learning Python. Yeah? There are many Python tutorials, courses, things like that. Do that. It's a prerequisite for the course. Right? Fortunately, if you don't know it, you don't need to be frightened. 1 week is way too much time to learn it. You learn it typically in a day or two, right? Because we are not going to need very deep and extensive Python or its esoteric features. We just need the ability to, create variables, store some values, write a for loop. That's about it. You don't need most esoteric aspects of Python. That's it. Make yourself very familiar with Python. Read the cheat sheets of NumPy, basic NumPy, and write a few basic plots with Matplotlib. Are we together? Right. And I will keep the rest of the learning for next time onwards. From onwards, so make sure that you baseline on this, guys, by end of this week, so that next lab that we do, we actually do machine learning. Are we together? We'll focus on machine learning. And that's it for today. Today I'll end early because I noticed that there is a bit of a band gap. There's a differential between where people are in starting places. So I don't want to rush ahead and intimidate the ones who are just starting out. Use this week to baseline, and then we'll make progress. That's all for today, guys.
So when is it?